Get ready for an unprecedented and cataclysmic space event that may irrevocably change our perception of the universe. Betelgeuse, the massive red giant star on the outskirts of our galaxy, has started sending ominous signals indicating it is about to undergo a gargantuan transformation. Using the sophisticated tools of the James Webb Space Telescope, scientists have made some ghastly findings about this giant star, and the consequences for the future are immense. Astrophysicist Brian has issued a stern and measured warning as we ask ourselves, are we on the brink of watching an event so great and cataclysmic that it will forever alter the night sky? Will Betelgeuse explode into a supernova shortly, ending its life in a dazzling and unimaginable release of energy? This star enigma has fascinated stargazers and astronomers alike, as Betelgeuse becomes increasingly erratic in its behavior and its position in the universe becomes increasingly unstable. Sitting in the shoulder of the constellation Orion, Betelgeuse was revered over centuries, both by modern astronomers and ancient cultures. A red supergiant star, vast and venerable beyond understanding, it has long been one of the brightest treasures of the winter evening sky. At about 764 times larger than our Sun, Betelgeuse is nearly beyond comprehension in size. If it were to take the place of our Sun at the center of our solar system, its swollen surface would extend past the orbit of Mars. In doing that, it would engulf Mercury, Venus, Earth, and Mars completely. Its size alone is sufficient to inspire wonder, but when coupled with its instability, it is one of the most interesting and unnerving stars humanity has ever known. Betelgeuse is currently in the last stage of its life cycle, the red supergiant stage. Betelgeuse-type stars live brief lives in comparison to Sun-type stars. After billions of years of burning hydrogen into helium, Betelgeuse has run out of its main fuel supply and has expanded outward, cooling as it does so. Scientists guess that it is 8 to 8.5 million years old, an age, though enormously brief in comparison with the Sun's 4.6 billion years, yet still ancient in terms of stars of such vast size. Time is running out for Betelgeuse. Its evolution from a blue, hot star to the cooler, puffy red giant that we observe now indicates that it is approaching the last stages of its cosmic tale. One of Betelgeuse's most notable characteristics is that it is not yellowish-white like our Sun, which burns at around 5,500 Kelvin. Betelgeuse's surface temperature is just around 3,500 Kelvin. This lower temperature provides it with its characteristic red color. But the story of its color does not end there. Historical records suggest that Betelgeuse has been changing before our very eyes, although the timescales are so long that only records across centuries reveal the shift. Ancient Roman and Chinese texts described Betelgeuse as yellow in color, while by the 9th century Arabic astronomers recorded its reddish tint. This striking change over the last 2,000 years is direct proof that Betelgeuse is changing rapidly, a unique chance to witness stellar evolution on a timescale intersecting with human chronology. Brightness is another aspect that marks Betelgeuse apart. It is a semi-regular variable star, meaning that its brightness changes in cycles of around 400 days, with further changes taking place over longer 5-year cycles. These fluctuations have been mapped over centuries, with astronomers observing its brightening and darkening over time. But Betelgeuse doesn't settle for predictability. It has a penchant for breaking these patterns in ways that leave astronomers scratching their heads. Its biggest enigma came in late 2019 and early 2020, when Betelgeuse experienced what was referred to as the Great Dimming. At this event, the star became so much fainter that even amateur astronomers observed it without the use of telescopes. The fade was so severe that for the first time in recorded history, the position of Betelgeuse among the brightest stars in the nighttime sky fell. It faded at a rate of approximately 0.01 magnitudes per day, bottoming out in February 2020. To most, this sudden diminution of light was alarming. Was Betelgeuse going to blow up as a supernova? The difficulty with answering that is the physics of light travel. Betelgeuse is some 725 light-years from Earth, which is to say that what we are seeing of the light from the star today left it over 700 years ago. In the real world, what we observe of Betelgeuse through our telescopes is not what it looks like today, but what it looked like in the late Middle Ages on our planet. If Betelgeuse has already gone supernova, we haven't yet seen the light of that explosion. We can be hundreds of years behind in being aware of its actual destiny. This phenomenon, described as the light travel time effect, is one of the most sobering truths about astronomy. When we gaze out at the stars, we are constantly looking into the past. During the Great Dimming, astronomers were quick to mobilize and examine it. Working with the Hubble Space Telescope and other sophisticated equipment, researchers led by Andrea Dupree at the Harvard-Smithsonian Center for Astrophysics closely examined Betelgeuse's outer atmosphere. What they found surprised everyone in the scientific world. Betelgeuse had spewed out enormous quantities of material from its surface, approximately 200,000 times more than the solar wind that our sun emits. This ferocious eruption produced a humongous dust cloud that swept into our line of sight, dimming part of the star's light and producing the spectacular dimming. The material, originally a burst of plasma from a huge convection cell on the surface of the star, cooled as it expanded, forming into dust particles that served as a cosmic veil. The magnitude of this ejection was nearly unimaginable, around 400 billion times larger than a normal coronal mass ejection from the Sun. It left the question tantalizing: was this enormous outburst merely a natural variation in the life of a dying star, or a sign of its eventual collapse? The question is still debated. Some astronomers believe that Betelgeuse might have thousands, or even hundreds of thousands, of years remaining. Some believe that violent activity on the part of a star, including Betelgeuse, indicates its demise is impending, potentially within decades. Although no one knows when, it's doubtful anyone can dispute that Betelgeuse is a star in decline. When it does happen, Betelgeuse will explode out in one of the most spectacular manners conceivable, a core collapse supernova. This is what awaits massive stars. When its core can no longer fuse material to fight gravity, it will collapse inward in the space of a fraction of a second. The star's outer layers will bounce outward, causing an explosion so intense that it will outshine entire galaxies for a brief time. Within days, Betelgeuse will emit more energy than the Sun will over its entire 10 billion-year history. For those on Earth to witness, the display would be awe-inspiring. Betelgeuse would shine so intensely that it would match the brightness of the full moon, observable even by day. For weeks, maybe months, it would dominate the sky, reminding humans of the raw and violent powers that rule the universe. Ancient humans who used Betelgeuse as a seasonal indicator in the constellation of Orion would hardly recognize their eyes if they were to witness its vanishing act, with its place being taken by a glowing echo of its demise. Earth is secure despite its might. 725 light-years away, Betelgeuse is close enough to provide us with an amazing front-row seat, yet far enough that the dangerous radiation emitted by the explosion will not endanger life on Earth. What we will be able to acquire instead is a once-in-a-lifetime chance to examine the demise of a giant star in close proximity. The information gathered will be priceless, providing information on the dynamics of supernova explosions, the formation of heavy elements, and even the birth of neutron stars or black holes. It is important to recall that almost every gold, silver, oxygen, and iron atom in the world was created in the cores of stars such as Betelgeuse. As it eventually explodes, it will seed space with elements that could one day form new stars, planets, or even life itself. In a very literal way, Betelgeuse's demise will be the seed of future creation. The unpredictability of Betelgeuse's timeline is what makes it so interesting. We know the eventual demise, but we have no idea when. It could have already occurred centuries ago and we are just anticipating the light to arrive. Or it will never occur for 100,000 years, long after humans will have abandoned the planet. This unpredictability reminds us that although we have learned a great deal about the universe, we are still reminded of its mysteries. For the time being, Betelgeuse remains to pulse, to dim and to brighten in the evening sky, a living reminder of cosmic impermanence. Every night that we can see it shining faintly red in Orion's shoulder, we are seeing a star reaching the end of its life, a star that someday might change our sky in a manner no human has ever witnessed. Whether its fiery conclusion comes tomorrow, within decades, or far into the future beyond our years, Betelgeuse's destiny is decided. And when it is time, the universe will present a spectacle of unmatched radiance, a reminder of the cosmic power, majesty, and fleeting nature of the universe. Until then, we wait and observe, aware that one of the brightest gems in the night sky is getting ready for its last, awe-inspiring act.